Well, hi, good morning. Thanks so much for joining me here in my shop for another round with this receiver. Yesterday I had lots of fun in here, but didn't actually get going what I really wanted to get going, which was the S-curve on the scope. Not exactly sure why that didn't work, but what I'm going to do is I'm going to stick with the instructions in the receiver service manual and just try to refine everything and see if maybe I just had a few things kind of out of sorts, and together they created the schmozzle on my oscilloscope. So first thing is this AFC connection point. A little odd that they would say AFC in my mind, AFC connection point, but I guess they got to name it something. Seems like absolutely the right spot when I looked on the schematic. Seems like the spot I would choose if I were going to just wing it off the schematic. Is there something more about this? Like, why did they do this? Why did they bring this out here? Why didn't they just mount all these parts on the board? So there must be more test pointing going on in here. Maybe in the next few steps we'll find out that more stuff has to be connected here. Similarly, the same sort of thing up here, which I don't really know much about. I think it has to do with the power supply, but I'm not sure. I'm not paying attention to it at all. But again, why is it here, sticking out like this? Is it a test point? Well, the instructions say quite clearly, follow the yellow wire down from the board, or the yellow wire marks the AFC. Okay, so in my radio, the yellow wire is turned green. This has to be it. There's no other wire. It lines up with this transformer, and I can see on the diagram in the service manual that the wire lines up with this. That has to be it. This is it here. Yeah, I can feel the wire. I don't want to be wrong here. It comes right up onto there. That's exactly where I have the scope connected. We'll leave it disconnected just for now. Okay. I've had my signal generator running there for a little bit, so it should be warmed up and stabilized. What about it and its settings? So I tried just about every setting on there just in hopes that something would happen, or maybe something would show up that would give me better insight into how to do things. No, that didn't happen. So I'm keeping the 19 kilohertz switched off, so there's no attempt to flip this into stereo. Again, this should really be sitting on the sweep mode. I believe in sweep they recommend this knob be set to a certain number of dots, believe it or not. 6, I think, is what they said. I'll have to check that, because in sweep mode this meter doesn't operate. If we look at it in this mono mode, you can see by setting it to 6, it's right on the 75 kilocycles. Maybe we can guess. It's still on 75. It's still doing 75 kilocycle sweep, which matches your standard FM radio station, I'm pretty sure. I don't think there's too much more to it. I have this wire here that I've got extended with the clip. Maybe that's not the best thing to do. Let's reduce that, because I can take this off, pull this out here. This may not be properly terminated. But all this is doing is feeding a 60 cycle sweep signal to the oscilloscope. I have a lot of trouble believing there would be a problem with this cable itself. Even shortening it, again, I can't see how that's going to help, but we're going to do it. Let's go this way. So that eliminates a big chunk of wire. Okay, we'll put this on the Y, on the X input here. X input. Horizontal input is what I really want to say. Okay. So chunk of wire out. Next thing. The scope lead I am using. So right now I am using an official Tektronix scope lead here. There's no switches on it. It says right on it ×10. And this is the one that when you plug that kind of scope lead into a Tektronix scope here, it changes the setting here automatically. So the most sensitive I can go is right there, 50 millivolts per division. Now let's center this up. Okay, it's filling the screen pretty nice. I'm going to shrink it a bit. There. So it's just kind of filling it nicely. I have the input set to AC, which I think is fine. If I set it to DC, there's a DC component here, which I think is probably a leak out of that generator. Push the scope display right off. So that's why that's on AC, and this one is set to DC just because. I'm guessing generally, if you can get away with it, it's better on DC. Now, there happens to be, and I didn't know this, a filter built into that oscilloscope. I've never noticed it. And sure enough, there's a 200 megahertz bandwidth limit. No, 20 megahertz bandwidth limit vertical mode. Full bandwidth out. So I push this button, a little light comes on. That's going to filter some of the higher frequency hash that might be on there. So I'm going to leave it off just now, so we start kind of where we did. See if it's the same. Sometimes I come in here and hook everything up and the picture's different. We'll see if that happens. So I won't hook this up until we have the receiver operating. Okay, receiver on. There we go. Regular voltage supplied to it. Okay. The RF signal strength coming out of my signal generator is at its minimum, lowest setting possible. What do we hear? Okay, so we're hearing the sweep. Now, one of the big issues here is having the receiver tuned exactly where it should be when I'm doing this work. If the receiver's tuned a little left or right, then I will align everything incorrectly, left or right, so to speak. So that's a real challenge here. Let's hook up the scope. I'm just going to move it here, get a little better look at the scope. Scope connected, we're getting the same weird stuff we got before. Okay, let me turn down the volume here. We don't have to listen to it. Okay, so I'm exactly what was there yesterday. Okay, a couple things to do. One is push that filter button. Let's just see what happens here. It doesn't seem to make any difference at all on there. Another one is I'm going to swing the sweep level up and down a bit, and see, I think it just changes the size of the display. It doesn't really do much else. I'll put it back to 70, what I think is 75 kilohertz of deviation, and there we are. Now, tuning the radio. I'm going to tune the signal generator back and forth because I know I can return it to exactly where it is now. So it's the same effect, I'm pretty sure. So it's stuff just moving left and right in there. So you would think proper tuning would be there, but maybe it's way off. Ooh, oh, this knob goes right around. It must be like a capacitor you can turn right around 360 degrees. So I'm guessing, so I have the knob exactly upside down. I'm guessing it's just the other half of the same capacitor, if you know what I mean. Okay, so it's set back to 100 megahertz. Where are you, S-curve? So we could reason out that the reason the S-curve is lousy, or that's it, and it's lousy, like really lousy, is because the radio's way out of whack. But I would think if it was way out of whack, you would not be able to receive much at all. It is weak on detecting the stereo pilot. Maybe it's generally weak. Maybe it's this. I don't have any other alternative except to start fiddling around with the transformer. Now yesterday I determined it was 205 that needed to be adjusted, but that may not be correct, so I'm going to stop for a minute, check out the service manual, just make sure which transformer it is or coil I should be adjusting here. Oh, I did make a mistake. It's TR205, and I saw the 205 here and ignored the fact that this is L205. TR205. Okay, so this makes a lot more sense to me, actually. So this is the transformer, well, hope I'm not wrong in saying this, the transformer through which the FM signal is passed. And the way this transformer is tuned, the FM signal will create an AM signal, amplitude modulated signal at this point, and that's what carries on through the radio from then on. So the purpose of this is to, I want to say convert, I guess that's a possible word, discover, create, maybe create is the right word, create a AM signal out of the FM signal. It's kind of a tricky way they do it. In a sense, instead of tuning this to the peak, you're tuning it to one of the sides of the response curve. Okay, I could be wrong in the way I'm describing this, so take everything I say with a grain of salt. I do, I don't believe myself. I have a lot of self-doubt when I'm doing this stuff, and unfortunately sometimes my voice projects the idea that I'm certain. No. No, it's a mistake in any kind of sort of pseudo-scientific environment to be sure. You should never be sure. Okay. Now, with that sense of insecurity, is it possible for me to adjust transformer 205? If you remember yesterday, just an example of how I'm so careful with myself. When I checked this coil, I barely moved the slug, and I noticed nothing whatsoever happened. And I said to myself, and I just left it at that. See? I'm smart. It's tiny portions of smartness in me. Okay, see if I can dig another one out here. 205 all by itself. 205 all by itself. So without the proper S-curve on the scope, adjusting this transformer is risky, because I may not be getting the feedback I should be getting as I make the adjustments. So first thing we're going to do is just check the sensitivity of the transformer and what kind of things it might do to this. Get my little stick in there. Okay, we're going to go in the upper slug, which I don't know if it's primary or secondary. I'm going to give you the close-up shot of the scope here. Oh, it just looks like the last thing in the world I should be trying to do this with. But here we go. A little bit of turning. Oh! What was that? And I have to tell you, that movement came after I stopped turning this thing. What? Let me turn it back. That's about back. Oh! It did it again. I wasn't turning the slug when that piece leaped in there. We better listen to this. What does this sound like? Okay, turning again, same as I did last time. Nothing's moving. Oh, there it goes. I guess I changed direction. Sorry if I scared you. I guess I changed direction there. Well, that's the weirdest thing. It's like I get to a point and zoom, it just takes off. Let me come back with it. Boom, another spot there. That's amazing. I've never seen anything quite like that. Oh, that's AFC operating. That's probably the AFC operating. That's interesting. I'm going to turn it off. AFC is turned off. It strikes me you should be doing this with the AFC off. Okay, now we're not getting anything. But look at the huge changes in the display. My gosh. Okay, let me put it back roughly where it was. I'm going down to the lower slug now. Trying anyway. Get in there. There it goes. Okay, I'm in the lower slug. These are having a huge effect here, but okay. How do you make sure this isn't totally out of whack? I think you're supposed to include a 10.7 marker frequency in here and give you some idea where 10.7 is on the screen there. And that's probably a big element I'm missing. I'm going to stop and just reread the instructions, and then I'll set up if it makes sense for the 10.7 marker to show up in there. We'll see if we can make all this work. Well, admittedly, I don't know what I'm doing here, but I'm having some fun. So what I've got is the signal generator over here trying to produce the 10.7 signal. And I've got it connected right to the antenna, same place as this signal generator. I guess what I'm hoping is somehow 10.7 will leak through the whole radio, get in the IF, and show up on the scope display. So things were going along okay, and then they got really interesting at this point. Just watch the scope there. So that stuff there, whatever it means, is showing up at 10 megahertz. 10.7. 10.7, I'm going up there now. Here's 10.5. 10.7 is right here. You know, it's affecting pretty much the entire display, but it's nowhere near what I need. Whoop, there's another jump there. That's 10, that's 11, just above 11. That's a little higher above 11. And then, ooh, something way up here. 12.5. I got no idea what I'm doing here. I could be mixing signals, all kinds of weird stuff could be going on. The one that seems most this one here. So the other ones are kind of blips. That's 10.6. That would hint to me, if I'm doing this at all correct, that the reason 10.6 is showing up on the scope the way it is because the radio's not tuned properly against the 100 megahertz signal. So let's just fiddle with that part of the deal here. So we're trying to move the junk towards the middle. Like that. Here we are, junk on the scope. Now I'll fiddle with this guy again. See what happens when we get up towards. So that's 10.8, 10.7, 10.6. This is just not doing at all. It's very odd stuff there. I'm just going back and forth across 10.7. And it almost looks like you could have like a mirror line here. And what happens on this side happens on that side. That's kind of like an S-curve, isn't it? Here we come on the left. And then you see it goes weird on the left, and the right shows up as I tune through. Let's put it right in the middle here. Right in the middle of this schmozzle. Okay, so it's possible different things can be going on. I can be overloading the receiver with both the sweeper and the marker generator, and so that's why there's a schmozzle on the screen. So, okay, on that basis, I don't think I can reduce the output of the sweep. It's at minimum right now. I'd have to pad it somehow. The marker generator this adjustment here. Well, it doesn't seem to suddenly make it go crazy as if you hit an overload point with it. Well, the next thing to do is to fiddle with that transformer and see what I can get. Let's see if I can get this to look just a wee bit better on the camera. It's a little bit better. Okay, now that's supposed to be an S-curve. It's the lousiest S-curve you've ever seen. Okay, wait a minute. Now I think I made a mistake. Let me just adjust the marker to 10.7 on the counter here. Okay. And I'm going to tune the radio and put stuff in the middle. That to me looks like it's balanced on either side. Okay, I'm going to start adjusting the transformer. I'm in the lower slug. Okay, I'm going to leave it just about where it was. I'm going to go in the upper slug, which seemed to have a lot more impact here. Let me just get the tool proper. Here we go. Upper slug time. This is nothing to do with an S-curve. It's completely. This is just hopeless. This is a hopeless situation here. What is going wrong? Son of a gun. Well, I guess a possibility is it's the FM signal generator is overloading the radio, and it doesn't matter what I do, it's going to look like a schmozzle. I'll try patting it down. I'll try maybe loosely coupling the generator with the receiver. So I'll take off the marker generator here first. I'll take this guy off. So, I mean, even like that, the receiver is receiving. Jeez, yesterday I think I raised the issue of can the signal actually go straight into the radio here, because there's so much radiating from here. Okay, watching the scope without touching anything. Well, I don't know. Is this proving anything? Put a little tiny, I'll put a clip lead on the FM antenna lead here. Well, that's entirely different. Well, why would that be so different? Okay, and that's a little more interesting, I think. Now, can we turn that into an S-curve? First, I'm going to hit that filter button and see if the hash doesn't disappear. Nope. What would we try next? I'll raise the RF output on the signal generator. Oh, look at that. I'm going to guess that what this is telling me is it was overloaded something horrible before. If I can do this with just a little bit of signal generator signal and nothing's even connected, that certainly doesn't qualify as an S-curve though. So, I mean, there are, you know, I could just walk away from the instructions and figure out my own way of doing this rather than try to make these instructions work. Oh, let me push that AFC button again. So it looked like that caused the radio to retune. What would it be locking onto? What if I shrink the deviation to nothing? What happens? And I think the sweep disappears. That's what happens. The sweep disappears. Well, that's far and away from any kind of a S-curve still. Nowhere's near it. is the scope grounded in the wrong way. I've got the oscilloscope just, you know, grounded in the normal way. I've just got the ground lead onto the chassis here. Is it supposed to be somewhere else? I don't think so. It just describes this as the AFC test point. And just in case you're not fully aware, I have this little test circuit that I had installed here. It's not connected to anything. It's just hanging here. Not doing anything. You know what? You know what I just remembered? I just remembered. There was a capacitor in here that was disconnected, and I connected it. Is that the mistake? Oh, wow. Hello memory. Hello memory. That's right. I found this capacitor unconnected. I reasoned out where it should be connected, and I connected it. It's this one. Is that in there? Is that in there? Is that supposed to be in there? That's the question. Okay, I'm going to find the answer to that question. Can't remember the answer. Got to find it again. Okay, so the part of the schematic we're concerned about is right here, this AFC point, and around it are some resistors sticking on that terminal strip, and I believe here they are here, 47K and 47K. Let me zoom in on this a bit. 40, R46 and R45, 47K each. So I'm going to look at the resistors on either side of what I think is the test point, 47K. Two 47K resistors exactly as we see here. There's no question I'm testing at this point. Let's follow all this stuff around. Where's that capacitor? So that capacitor, there's a couple of capacitors involved. There's a diode in there. Well, it looks like a diode from what I can see here. So the capacitor is connected on one of the... Oh, you know what? That capacitor's on it. No, I'm totally mistaken. Okay, totally mistaken. Totally mistaken. I'm looking at two things at once. The capacitor is actually on another terminal strip. But it still raises the issue. It could still be involved in this. It's just not where I thought it was at all. Up where it is, there's a diode. What is that? So I'm gonna find out where the mystery capacitor really is. The mystery capacitor. And it can't be like this dotted line marks the edge of the circuit board. So this stuff outside of the line is all outside of the circuit board, and everything here is on the circuit board. The stuff I'm looking for is off the circuit board. 10 microfarads. You know what? There's a large... That's another terminal strip with stuff on it. With an electrolytic capacitor. Little tiny electrolytic capacitor. This one right here. 10 microfarads. What is this guy doing? What's he hooked up to? 12 volts. AM. Well, you could be you're switching power. Yeah, I'm not sure what it's doing. It's related to. Looks like it's related more to the AM radio. Maybe I can't really be sure. Can't be sure looking at this. Okay, too many things. Too many things on the plate here. Let's go back to try to find that capacitor. So I need to find. I think I need to stop the video and figure this out, and then come back. So the fact is, with a radio like this kind of complexity, I am not going to understand the purpose of much of the components in this radio. The majority of them I am not going to understand. But that having been said, I remember now. This is the disconnected capacitor. I found it was disconnected in the radio. Appeared to have just popped off the circuit board. The lead did. I'm not sure. Did somebody disconnect this on purpose? Don't know. Look where it goes. It goes right right into a transistor that's involved with the signal being fed into the IF. What could this be? So it's a capacitor. It can't be any DC thing. For a while I was thinking it was some kind of level control, because if you go on the other side here, we end up pretty much at the antenna. Here's a statement: automatic gain control plus 1.4 volts for no input here. So you think, well, I guess you got a higher input. This kind of looks like an attempt to develop a DC voltage from the FM signal coming in. It's kind of what it looks like to me. And then what would you do with it? Yeah, I don't know. Or is this going the other way? I mean, it's going the other way. Yeah, maybe it's the other way around here. What's really happening is the output from the FM receiver, a piece of it, is being rectified, and the result is being pushed up here to change the base voltage here. Now, I don't know how transistors work in terms of gain variation. My vague understanding from so many years ago is you can control the gain of a stage with resistors around the active element. Don't see that happening here. So maybe pushing the base up and down on this transistor will change its gain. Is the same thing happening with this one? It doesn't seem to be. I'm just guessing too at what's going on here. So then, if that were the case, what is this signal? What is this? Number 6 plus FM. Plus FM. Is there a minus FM somewhere? There's a test point I hadn't noticed before. It doesn't have a number, it just says test point. This transformer I have fooled with. I cannot reason out what this capacitor might be doing. What if I just cut it again? What if I just return it to the way it was? I don't think it can cause any harm. Just further embarrassment for me. Well, I don't know what else to do, so we'll do that. So we'll disconnect this little capacitor and see what the action is. I think I can just cut it. Just cut it free while the radio's operating. Doesn't that sound scary? Do you dare do that? Reach in there and cut it. Or did I connect it to the wrong spot when I thought I connected it to the base? Maybe I connected it to the wrong spot. Well, first step would be disconnect it entirely and see what happens. Now, the end that's connected on the circuit board, I should probably release that end rather than cut it back here, because it's going to leave an antenna sticking off the circuit board. Okay, got to shut her down and desolder. Okay, let me do that. I got to go outside and just see what my cats are up to. I'm afraid the situation's not getting any clearer here. So again, capacitor, I think, is the disconnected, reconnected one, is this one. I remember right, the size was correct and everything. This position is correct. I can see the diode, I can see the far side is grounded, and I can see this resistor. I can see this, I can see this. This I have connected in accordance with the schematic to here. This is the transformer collector. It's connected from the transformer to the center tap of this transformer. Did I say transformer here or transistor? So in effect, this is connected to here and to here. Now if we look at the circuit board for the same spot, Q203, T looks like 1537 for the transistor type. That's probably the stock number for the company that built this. Q203. So we'll look on the schematic now. Oh, this is a schematic. We'll look on the board diagram here. Let me just flip this. Oops. Where are you? Q203. Where are you, man? I've lost you. Here you are. Q203. Here it is here. Q203 T, looks like, I don't know, T1S37 or something like that. That's definitely the correct transistor. This is the collector. Look, they even have a little diagram right here. Collector. And you can see the collector, you can follow the trace here, goes to the center tap on the transformer, exactly as depicted. Where's that capacitor connection? And they would normally, if they're going to bring a wire up here, they would pop a hole in the board here and stick the wire through it. Like this one. But there's no wire, there's no connection. The board diagram shows no connection, but the schematic does. I found the receiver with the capacitor disconnected. What is going on? Obviously, my option is to disconnect it and see what happens. Okay, there it is hanging out here, kind of the way it was originally. Okay, I think we're ready to try again. Let's just leave it loosely coupled down here. We'll just pick it up right from here. Power on. Here we go. Okay, my first glance says, well, that didn't make any difference at all. That's my first glance. Okay, how disappointing. I was hoping I'd snap it on and there'd be just an S-curve sitting there. Yeah, right. Well, that was much ado about nothing, I think. I would be tempted to push it in there and make contacts on and off, but there's actually a note right in the service manual that says make no connections while the unit is operating. So turn it off, make your connections, turn it on. That's a standard procedure. I don't normally follow that with vacuum tube equipment because nothing is so sensitive, but in this case there's a lot of stuff here that could just pop and be gone. Well, what an annoying situation. The radio really needs to be aligned, there's no doubt about it. Well, yeah, there's always doubt about it, but I think I gotta stick with this until I can make it work. And when will that be? Oh my gosh. I just don't know. Oh. Okay, so I'm gonna turn off the video. I'm gonna play here all on my lonesome and see what I can do here. Okay, here's a crazy thought. I've connected at the end of this yellow wire way down here, thinking this is probably where they really want you to connect your equipment. But I have looked back up where the yellow wire comes from, and there is a little test point loop sticking out of the board there. So I'm just going to move my oscilloscope lead up there, see if a presto occurs. Okay, let's get it off here. We're going to ground this to the chassis. It's just a little more certain. And now test point. Did it say something about don't connect your equipment while it's operating? Okay. That's essentially the same place, just the other end of the yellow wire, and I got exactly the same result on the oscilloscope. Why does it look the way it looks on that oscilloscope? Can I wring some intelligence out of that? Can I wring some intelligence out of my head about it? It's an interesting display in that they have this area in the middle which is being affected by, obviously, the radio. This isn't the best, hard for you to view this if I pour a little more light on it there. I'm trying to trick the camera into showing this properly, but not doing the best job of it. So this looks fairly symmetrical in here. There's a little humpy spot, a little humpy spot. Let me change the frequency of the generator. Yeah, the stuff moves back and forth. Go way off. That's going right around. And I'd have to think that that is tuned very properly to the radio. What is going wrong here? AFC button. Where's that now? That's AFC off. AFC on. Now I'm going to look on the schematic and see where that switch is and what it's doing. I believe the instructions are to have it on though, but I'm going to take a peek here. You really got to like puzzles to work on something like this. So here's the switch. There's a note over yonder here that says all switches shown in off position. So this is the off position. So in the off position, a short is applied here to the ground, grounding this line through a large resistor at 0.5 watt, a large 0.5 watt resistor. So expecting a fair bit of current to come down here from, well, I don't think it's going to come through here. It's got to come right off the board here. Some heavy current? Wow, that's hard to believe. I'm probably misinterpreting things again, but nevertheless, what it's doing is in the off position, a ground is applied. So this is kind of partially grounded here, right to the terminal I've got my test probe on. It's also applying a firm ground back to the antenna on the AM side. Why in heaven's name would it do that? Because it's really doing something this way. It's ground. This is what? What? This is grounded already. This is grounded. So it's, what is it? What's going on? What is this? This is a ground terminal, isn't it? I don't see any other symbol anywhere. This has to be grounded. Oh my gosh. What are they saying here? So the AM antenna signal comes in, goes through this little tiny loop coil here to the chassis. That makes sense. And then fires up this coil and off it goes to the radio. That's fine. Why would you want, when the AFC is off, a ground is applied? Here? Am I ever lost on this? This is just... well, this has to be the AFC switch. It's just a simple switch, isn't it? Can I see it? Can't really see it. It's hidden away. I can't really see it, but I'm sure it's just a simple switch. That is the, yes, that's definitely the AFC switch. No doubt about it. Well, I can't make any sense of what's going on here, except it's applying a light ground, if you like, to this test point. And I would imagine, aside from what else is doing up here, because let's follow this one. Okay, so it'd be, with the AFC off, a ground is applied, well, to here. Looks like 100,000 ohm resistor. Yikes, and into here. You know, I don't exactly understand how AFC works. It must generate some kind of error signal which is applied to some active component which alters its resonance somehow. Something, I don't know. I don't know. Admit it, Jim, you don't know. Oh my God. You ever think about life as you go through life? You've got a thimble full of things you know and a barrel full of stuff you don't really know. And we try to get through life without ending up in the barrel. Just hang on to your thimble full. I'm becoming philosophical, which means I'm really at my wit's end here on this. Well, let's push the button and consider what it's supposed to be doing. So I'm going to make it off right now. Where is it? Okay, that's off. When it's off, we have this grounds put on it. Notice things got quiet. There's a ground on here. The display looks completely different. The display looks completely different. So you're sticking a ground, even though it's through a big resistor though. A big high wattage resistor. I mean, can you get current coming out of one of these guys? I can't imagine there's a supply of current significant enough to heat up a half-watt resistor. Well, it's not the biggest resistor in the world, but I don't get it. Holy smokes. Well, it strikes me, placing a ground even on the other side of a resistor here would just reduce the signal here, wouldn't it? And this is a signal that's going on and eventually coming out your speakers. So it's off and the radio is quieter. I'm going to put it on. And the radio gets louder. Now I interpreted that before, that the AFC was tuning the radio in. Let me check that. A little bit boring to stare at a schematic. This is really exciting. Okay, pushing the button. Ground is in place. Things have gone quiet. What's happening? And so what happens on the AM side during this? Now, I've been ignoring the AM radio here. Let's turn it on. I'll push that AFC button. Gosh. I mean, I apologize if there's been telephone interference on this video while I've been making it. I have my phone in my pocket. Okay, I'm going to push the button. This will release the ground. No, actually, the other way around. I just turned the AFC off, placed the ground, didn't do anything. I mean, you can't expect the AFC button to affect the AM radio. So I don't know what I'm seeing in that schematic. Well, I've gotten exactly nowhere. So regardless AFC on or off, there should be some signal there. But have a look. I'll put the better camera on here at the tremendous change in what this looks like. Okay, and just the AFC button. It looks like it tuned it in. So AFC off. Sure looks like it just tuned it in. Let me tune the radio here. Yeah, I think that's all that's happening. AFC on. Oh, threw it way over there. What's that mean? Okay, tune the radio. I'll put it over there. AFC on. Even further. Well, okay. There's the end of my session today. I didn't sort anything out here. Oh my gosh. What is going on? Let me just do one more. I'm going to hook this back up here, right onto the antenna. Give it the works. This is the sweep signal generator, or FM signal simulator. So I still have the RF output at minimum. Change the display a fair bit. There, have a look. Let's fool around some more. Okay, first of all, the tuning of the radio. Okay, so I got the junk in the middle. Turning up the RF gain, RF output. Doesn't do a lot, does it? Except when you get here, it really dies out. So don't go there. It'll stay up a little bit. And is that the S curve hidden right there? Oh, look at how terrible that is. So My poor cameras here. I'm going to try to adjust that camera so it's a little bit better. I've been noticing, and I've received comments about bad camera focus. And I'm not going to argue about it. Here, let's just try this. Oh my gosh, look at that. I must never rely on autofocus. I apologize profusely for out of focus videos. It's a much longer story behind that, but I won't go into it. So we can't make this any more sensitive than it is. Raising the RF doesn't raise the image. Yeah, what? Adjust that transformer. Adjust that transformer. Okay, I'm gonna try it. So I'm gonna stick her in there. Okay, we're in the top slug. Depending upon which way you look at it, actually. And turn this around. I should really be tuned into a radio station and do this a bit. Go to the bottom slug. Oh, look at that. Is it just a matter of getting these two to create the S? Is there an S in there and I don't recognize it? So I've got slug interference here. To get the tool to go between slugs, you have to align the slugs to get the tool to slide. Anybody see an S curve? Is there an S curve in there? So it's possible that, I'm getting like a bottom and a top. If you dioded away one half of it, would it start looking like an S curve? What I have to do is get a little more in my head about where the S curve comes from. I've read up on this before and I had it in my head before, but it's leaked out over the last year or two. So I want to re-establish my understanding of why there should be an S curve, and maybe that'll help me a little bit. Because right now, what do I got there? Oh my God! I don't know. I got two planes breaking the sound barrier or something like that. I don't know. I'm stopping. I think I'm stopping for the day here. So thanks a lot for watching this schmozzle, and I hope you're getting something out of it, and I hope I'm getting something out of this, but may not be the case. It just may be the case that really, until I figure out which brick is missing in my wall, I'll never sort this out. And I think I got to make one last comment here. So the idea of doing the alignment at this point is to try to prove that the alignment is not the cause of problems in the radio, and there's a component causing a problem. And the idea is if you can't align the radio, then that's a strong indication that there's a defective component or components in the radio. And maybe that's what I'm up against. Maybe things are out of sorts because of something, capacitor or something like that. Maybe in the detector circuit or something. Who knows? I don't know. So it could be that I'm going to bang my head against the wall here forever until I find the defective part. That's what I think. I don't know. I don't know. I would think that's not the case, but I'd be more inclined to imagine what's going on here is I just haven't got things done right. But maybe not. Anyway, my head is pretty bruised, so we'll see you on the next video. Thanks again for watching. Bye.